This is the schematic diagram of our prototype smart switchboard. Now we are using an ESP32 as a central controller. This ESP32 is further connected to different IOs. We are using a current sensor AC712 which is connected with the AC. This is measuring the exact amount of current being consumed by this board. Now this is connected to the DC input. But we are using AC input because we are measuring live loads over here. We have also left space for a power module. Now for motion sensing, we have used an ESP32 cam and a PIR motion sensor. The purpose of this both is to detect the presence of a human being, also to and give signal back to this ESP, which will give it to Blink and display it on a Blink interface also. Now for data logging, we have used Blink app, but also we have left space for an micro SD card reader. Now we have used optocouplers for opto isolation because we have to drive relays, and these relays will be controlled by the user via touchpads or by the Blink interface. Now the purpose of this opto isolation is for the safety purposes of ESP32. These optocouplers are further connected, as you can see here 1B, 2B, 3B with this ULN IC. This IC is further connected to these relays. Now we have used indicator LEDs if this particular relay is on or off, and also we have used indicator LEDs with these touchpads. These touchpads can be manually controlled and also with the Blink app. Now this is all for the dynamic load, but if we are connecting static load, but if we are connecting a dynamic load, we are going to need to use a dimmer module. The purpose of this dimmer module is for the dynamic loads to control these loads. If we are using a fan and anything like that which works on different voltages, so we will use this dimmer module, which is also connected with the main ESP32. Now I'm going to show you the hardware which we have developed for the first prototype of a smart switchboard. This is the hardware of this circuit, the prototype board, switchboard. Now as you can see, this is the ESP. The resistors you can see here are being used as a jumper because we developed this board locally and there were certain faults in the tracks and some issues. Now this is the Wi-Fi indicator LED which will keep on blinking for when searching for a Wi-Fi, and it stays stable when a Wi-Fi connection has been established. Now these two ports are dedicated for the SD card module for data logging, and this for timekeeping. Now moving on, these are the optocouplers for opto isolation like I explained over here, and then moving on to the relay driver ULN over here. Then this will drive these 4 relays, and along with these there are these T blocks where we can connect our loads. This is for the main power supply. Now as we know, there are certain sensors like the ACS for the ESP, and for ULN we need 5 volt DC. For that purpose we used a 5 volt adapter connecting with this, and this is the place where we will connect this ACS for current sensing. And over here, now this is a 2-layer PCB front and back. Over here we will attach the ESP32 cam, and over here the motion sensor, PIR motion sensor. These are the touch pads like I mentioned here, and the dimmer module was connected separately via this port. This was the prototype we developed, and it was pretty much functional and working, but we improved the circuit, made it smaller, and then we developed via JLC PCB. That I'll be explaining in the next video. Thank you. This is the hardware of our prototype SSB SMEHA smart switchboard which we developed previously. Now as you can see, this is the ESP. Like I told previously, this is the ESP, and moving on, these are the ports for data logging for